As we already discussed about of LED, light emitting diode. So here we are connecting all LEDs, 7-segment display in common cathode mode. Cathode means all the cathodes are connected to one single wire and which is connected to ground. Means here you are giving A, B, C, D, E, F and G. These are your input pins, and that you can give either 0 or 1, either 0 or 1, either 0 or 1, either 0 or 1, 0 or 1, 0 or 1, 0 or 1. For entire 7 segments, you can give input as either 0 or 1. Any one of the digit can be applied as an input signal for this circuit. And next one is optocouplers. The name itself, it is indicating it is having a coupling circuit which is using optical circuits. So usually these optocouplers is a solid state device like a simple electronic components they will use to construct one solid state devices, or solid state components are going to be using to construct or fabricate or manufacture to a device, and which will use to isolate two parts of a circuit. Okay. So usually it will combines the LED and phototransistor in a single package. Single package means just like an IC. So in one particular IC, here we are going to combine LED and phototransistor. Both the components are going to be fixing in one single package, which we used to call it as one single IC. So mostly by using optocoupler circuits, we are suppressing, reducing interference in communications. So we are suppressing the interference in between. For example, I just sending one information from X to Y through I have one channel. So when I am sending or when I am transmitting one data from X, I have only one channel. In this channel itself only I used to send the data to Y. When the data is traveling in data path, there is a chance interfere. There is a chance of colliding the external noise along with the transmission data, which is original data. So now I am sending original data along with noise to the receiver Y. Means now X sending one information. For example, my information is ABCD. So I am sending information of ABCD to Y. Y receives A, B, C, D, maybe. So X, Y, Z. Here X, Y, Z is the noise, which is an unwanted signal, and ABCD is the which is sent by the information to from X. So here is one, I have one more example. So this is my IR diode. So which can used as a pure LED light emitting diode. When we are giving input signal as 1, then obviously this diode will get on, and then the light will emit from the diode, and that light will becomes an input for this transistor, and we used to call this transistor as phototransistor. So based on the light emitted by using this particular diode only, this transistor is going to be operating. So this is entirely we used to call optocouplers. But traditionally we are using these optocoupler circuits in between any one of the two circuits. Here is you have one more example. So here I have an LED This is my LED, and this is one more my phototransistor. So this is entirely called as optocoupler, and here it is having a MCT2M. The series of optocoupler is MCT2M. It is a series of optocoupler. Here also MCT2M. I am using one optocoupler 2, and here is this optocoupler 1. So here I am taking 8951 Atmel. What it is? We usually call it as microcontroller. So whenever you need to operate any one of the microcontroller for the purpose of isolating of a circuit, then you need optocoupler circuits over here itself, and at the same time over here itself. If you observe this entire circuit, there is no difference in between part 1 circuit and part 2 circuit also. Only the difference is here you are applying input interference, and here you are collecting output interference. Except that there is no difference in between this optocoupler 1 circuit and this optocoupler 2 circuit. Okay. So next one is stepper motor. We usually call it as General Motors. So motor usually used to convert electrical energy into mechanical energy. So motor basically used for the purpose of converting electrical energy into mechanical energy. So usually we have our motor, water motors, so having 1.5 HP. So water motors. So most of the time nowadays everyone is using for motor waters, either it may be 1.5 HP or it may be 2 HP or it may be 2.5 HP. That depends upon the length dig inside the earth. So let it may be 2 HP, 2 horsepower. So we are just switch on our electrical energy, then the current is passed to the motor, then the current passed to motor. So current is passing, then the motor converts this electrical energy into mechanical energy. Based on that mechanical energy basis, the water which is available under the earth will be pumped to outside of our water tank. Whether it may be on the top of the roof or it may be top of the earth, but the water is coming from under the earth. Means it is converting electrical energy into mechanical energy. Because of that one only it is possible to send the water from underground to top of the roof. And the second one is it produces discrete rotation. Discrete rotation means, so if it is a continuous signal, we used to call it as continuous signal, sinusoidal signal. For the same continuous signal, if I would like to draw a discrete signal, means it will come like this. So it is just under the shape of sinusoidal signal, which is available over here itself in continuous domain, but here it is discrete domain. Means a specific interval basis it has been segregated as a discrete parts. So for example, from this to discrete signal can be possible by using sampling only. So sampling means, so I have an input signal having a frequency of FM, like modulating signal FM. So whenever I am doing sampling, I need to cut the entire sinusoidal signal or else in message signal or input signal with 1 by 2 FM. 1 by 2 FM. So if I'll calculate like this, for example, FM is 5, then 1 by 2 FM becomes 1 by 5 2s are 10, that is nothing but 0.1. So I would like to segregate this signal from 0.1, 0.1, 0.3, 4, 5, 6, 7, means T1, T2, T3. Difference between T1 to T2 is 0.1 second. Same time T2 to T3 also 0.1. T3 to T4 is also 0.1. The difference or the difference between any one of the interval from T1 to Tn is 0.1 only, because we are doing the sampling on based on 0.1 only. Why? Because I have taken formula as 1 by 2 FM signals. So where FM is 5H, then obviously I will get 0.1 as my interval. So discrete rotation means it will take, for example, so this is rotation 1, rotation 2, rotation 3, rotation 4, or step 1, step 2, step 3, step 4. Whenever motor is going to be rotating, it has to rotate from S1 to S2, and then S2 to S3, and then S3 to S4, and then S4 to S1. It has to rotate, either it may be in clockwise direction or it may be in anti-clockwise directions. Mostly probably these motors are useful for robotic control systems and industrial applications. In this stepper motor, we have two modes of operations, depends upon the motor capabilities or motor winding arrangements. So first one is unipolar and second one is bipolar. As the name itself it is indicating, unipolar means it is having only one polarity, and uni means one. Uni means one and polarity, one polarity, and bipolar means it is having two polarities. So what is that one polarity and what is the two polarity, and how unipolar stepper motor is going to be operating and how bipolar stepper motor is going to be operating? Let's have a look. So this one is unipolar stepper motor. So any one of the motor, this M for motor, M for motor, and it is having 4 windings. So first one is A, and second one is B, and third one is C, and fourth one is D. I have 4 windings with having a capability, having a relation with motor. So whenever I need to operate the entire motor in unipolar direction, I have only 2 options. Either it has to rotate in clockwise direction or anti-clockwise directions, right? So how a motor can be transferred or operated in clockwise direction or anti-clockwise direction? For example, I have windings as A, B, C and D, 4 motors, 4 windings I have, right? So first one is A, second one is B, and third one is C and D. As the motor has to operate, I would like to having a relation between 1 and 3 and 2 and 4. 1, 2, 3 and 4. So now it becomes 1, 3, A 1, and this one is 3, and this one is 2, and this one is 4. How 1 and 3 and 2 and 4 both are going to be operating? Based on that only motor is rotating from either it may be in clock direction or it may be in anti-clockwise direction. For example, A and C both are rotating clockwise directions. Both are energizing this clockwise direction. Then the motor is rotating in anti-clockwise direction. Means when you are giving current or power supplies to the windings in clockwise directions, then the motor is operating in anti-clockwise direction. If you are giving anti-clockwise directions, then the motor is operating in clockwise direction. So means how you are operating the windings, either it may be in clockwise direction or anti-clockwise direction. If you are operating the windings in clockwise direction, then the motor will rotate in anti-clockwise direction. If you are operating in anti-clockwise direction these windings, then the motor will operate in clockwise direction, reciprocal, opposite. So this is the internal structure of your windings. So I've already told you now, this one is 4 windings. So first one is A, this one, you can check it out over here itself, and this one is C, and next one where it is B, and this one is B, and this one is D. So so this one is A, this one is B, this one is C, and this one is D. I have 4 windings. It has to rotate this, either it may be in clockwise direction or it may be in anti-clockwise direction. If you are giving your inputs to the windings in clockwise direction, then it will rotate in anti-clockwise direction. If you are giving your inputs to the windings in anti-clockwise direction, then the motor will rotate in clockwise directions. So here second one, which is we used to known as bipolar stepper motor. So in this bipolar stepper motor, we have 3 types of steps. The first one is full step, and second one is wave step, and third one is half step. So let's have a brief discussion about a full step. So whenever I need to take full step, means I would like to change the position of my motor. So this is my step 1, step 2, step 3, and step 4. Initially my rotor winding in position S1, if I will apply coil A as high and coil B is also high. If I apply both are in high direction, then obviously it will directly turn from S1 to S2. The turn direction from S1 to S2. The next step, I need to turn this winding from S2 to S3, but I can't able to change at a time. So then I would like to change first one, coil A as low, from high to low. I would like to try to reduce the power of coil A. At the same time, I'll keep the power of coil B as same as, because if I'll take the step low over here itself, then immediately the winding is going to be stopped. It won't work or it won't rotate. So I need one more coil. It has to operate this one. And next one, for the high support, I would like to change the coil C supply from low to high. Then obviously it is having 2 higher mode operatings. Here also you have 2 higher mode operations. Whenever you are applying 2 higher operations, then S2 will come to S3, then rotor will come to S3. Again same, so these are both are lows, so I don't want to change this one. I would like to keep it as a low only, but here it is high, so I would like to reduce to low. But if I'll reduce over here itself, or if I'll reduce this high also low, then the rotor will getting stopped. So I don't want to change it. So let it be with high intensity only. But here the next coil D is in low mode. So I would like to change this to higher mode. Then again I'll get 2 high modes of operations. So again it will change from S3 to S4. It change the operation from S3 to S4. Still I have 4. So I would like to keep any one of in high mode only. So I would like to change this one to lower mode. This is same as lower mode only. Here I have only one higher mode. I want one more also. For that purpose, if it is rotating and based on a clock or anti-clockwise, then here I have higher mode, and here I am changing from low to high mode. So means I have 2 higher operating modes. Again, the rotor will change from S4 to S1. Means for completing one complete rotation of a winding, you need to operate 4 steps. In full step, that is what full step it is. Means it won't operate in between the steps, like it can't able to change in between. Here there may be a chance to get stopped the winding, or there is a chance to stop over here itself, or there is a chance to stop over here itself, or there is a chance to stop over here itself. But I am not preferring to choose my winding to stop any one of the in between the stages S1 or S2. So there is no stop between S1 and S2. It is directly changing from step 1 to step 2 only. For that particular purpose only, I need 2 higher coils, higher operating mode coils. And here also from S3 to S4 it is directly changing. There is no stops in between that. Any one of the 2 steps in between, there is no stops specifically. This is what it is. Full step means step 1 to step 2 directly it is changing. That's what exactly over here itself is a physical representation. So these are my coils and this is my motor. So whenever I am starting from motor, step 1 is nothing but here my step 1 is here my A. I would like to represent it as step 1. So then I am applying 2 coils, coil A and coil B. This one and B, coil A and B, both are in high mode only. Then this one can be rotated from directly S1 to S2 only. In between there is no stops. So second one is, this is S1, this is S2, and this is S3, and this is S4. Same as S1, S2, S3, S4, S1, S2, S3, and S4. Okay, right? So when it is directly from S1 to S2 is rotating, but it needs 2 higher inputs. That's what we are providing for A and B. But if you suddenly change and you're giving to A and B only, again these 2, it cannot be directly change. It's a step from step 1 to step 2 or step 2 to step 3, because when you are switch offing or when you are reducing the powers of this one and this one to low levels, then obviously the internal winding rotating process is going to be stopped. So I would like to keep this as H only, and then I'll make this one as H and I'll make this one as L only. Then I have a chance to rotate from here to here like this. S2 to S3, there is a rotation. But here I am using B for a H and this one also for higher only. Same as this one. Whenever I need to change this one, here I need to use H, here also I need to use H. If I would like to keep to, again first position, either these 2 or these 2 has to be in higher mode. These are full step operating modes of stepper motor. So this one is, second one is wave step. So wave step means which will have some little bit disturbance in between. The name it is indicating wave means having some disturbance. So let's have a look over this. So first one, initially I am maintaining coil A in higher mode, right? So as we already know this. So S1, S2, S3 and S4, 4 modes. So initially coil A, I'll let it be A, B, C and D. These are the 4 modes, 4 positions. So initially I am maintaining coil A in higher stage. So when I am maintaining here in higher mode and the remaining 3 are in lower modes, then obviously it will try to change the position from S1 to S2, but it will not support by the supply voltage because we are not giving any 2 highs, S1 and S2, both coil A and coil B. I am not giving any 2 higher inputs for any 2 of the coils between this. So I am giving only coil A in higher mode. For that particular purpose, the winding from A to B, it will try to change the position from A to B, but it will take some time. Slowly it will change the position from A to B. But in next step, I will switch off it to low, change the position of coil A to low, but immediately for support purpose, I am changing the position of coil B to high. Even S2 having a high also, but the winding still not yet reached S2. If it is reaches S2, then S2, the high input voltage will supposed to turn the ankle from S2 to S3, but a rotor will not yet reach S2. So it has to wait for some time until the rotor has to reach S2. It has to reach S2. Until that extent, S2 has to wait. In this meantime, what is the output? Nothing. There is no output because it won't operate at S2. It has to wait until ankle or winding has to reach S2. Up to that extent, it has to wait. Okay, let's have next step. So I am here changing the operating modes from high to low in coil B, but immediately coil C I am making high. Means here it is, I am providing high, but it is not yet reached C also. In all stages, whenever you are changing the steps of coils, either it may be in coil A or it may be in coil B or it may be in coil C or it may be at coil D. Whenever you are changing the power of coil or input of coil to higher mode, it has to wait for some time to receive the winding or ankle or lever to S2. For that waiting purpose, from this step to this step, in between these two and in between these two, and even the next rotation will becomes, fifth one becomes high, and this low, 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 and the cycle will repeat. So these 4 motings, there is a chance of delay. Here also delay, here also delay, and whenever it is changing from here to here also, there is a delay. So if delay will exist, motor will not operate properly in between any 2 steps. So for that particular purpose, I have to choose for half wave step, half step, not half wave, it is half step operating mode. So here, same as I am maintaining coil A as H, just like an half wave only, and the remaining coil B, coil C, coil D in lower mode only. In the next step, I would like to keep this as same as H. Same time, I will changing the coil B in higher mode, and coil C, coil D are in lower mode only. So whenever I am providing 2 higher modes, then obviously it has the capability to change from position A to position B. Like, so this is A, B, C and D. As per our language, step 1, step 2, step 3 and this is step 4. So the lever has to be positioned in S, position at A only. So when you are giving higher input, then it will start to travel towards to the S2, means it will be stuck over here itself. it is trying to, means from the angle is trying from A to B, trying to reach from A to B. But I have only one input supply, coil A in higher mode. Because of this one only, angle started to reach step 2. Up to that extent, it has traveled. But once it is traveled, in next step, I have changed the coil B also in higher mode. Then means this is also in higher mode only. When I am providing both are in higher mode, then obviously this angle will reach step 2 for this entire cycle. So in third step, I would like to change this one to lower level. But if I'll change this one also to lower level, rotor will not move. For that particular purpose, I'll keep this higher mode as in higher mode only, and remaining are in lower modes only. And the next step, I'll keep this H higher mode as higher mode, and I'll change this lower mode to high input power supply. Then I'll get 2 inputs are high. So obviously I'll keep this one as low only. When I am having 2 higher modes, then this one is traveled towards to C and it reaches C safely. But in step 3, I have only one H, so it has to travel from B to somewhere in the position between. So this is also somewhere in between, same as like C and D and D and A. So now how many steps you have? This is S1, S2, S3, S4, 4 steps, and in between each you are having one more step. Likewise, step 1, step 2, step 3, step 4, and first step will comes by this. This is S5, and over here S6, over here S7, and over here this is S8. Now I am getting 8 steps. So initially I have only 4 steps in full step, but when I am segregating each step, means from S1 to S2, only one step is there in initial stages. But now I have S1 and S5, 2 stages I have. And next in between S2 and S3, I have S2 and I have S6 also. And next step S3 and S7, and next one S4 and S8. Each and every step has to be segregated as 2 half steps. So that is the reason half step means it's exactly half of the full step. So this is what we are doing. Initially, we are applying only first one as higher mode, and second step, I'll keep this higher mode as same as, and I'm giving the next one also in higher mode. By doing that one only, so when you are giving only one higher mode, then this rotate tried to move to reach the B, but only I have one high power supply. So there is no sufficient power for this to reach B. Because of that one, it has been stopped in between A and B. Then I have provided B also in high mode. Then obviously it has to change like this. When it is reaching here, my options are I have this one H and this one is also higher mode only. So then there is no use of this one, so I'll change this one to low power supply and I'll keep this one as high only. Remaining nulls, this one is low and this one is also in low. So once you have step 2 as higher input mode, then obviously this angle will try to reach this S3, but I have only one high power supply. So there is no sufficient power to reach this angle to step 3. So due to that, it has been stopped in between these two. So here I have already high. For that, this particular angle has to reach this side. For that particular purpose, I am changing this L to high, low to high. Once I have 2 highs, then obviously it has been changed to this direction. So now I have here high and this one is also in high. Now I would like to change this one to low. I'll keep this high as same as, and then obviously it will try to try to get into this direction, and then I'll make this one as high direction. If I'll keep changing in all directions, then it will come to the final position. This is what half step it is. And the next one is simply relay. So relay is an electromechanical device. So simply like it accepts electrical supply, it accepts input as electrical supply and converts into mechanical energy. So relay is an electromechanical device. So it is not converting, it is having mechanical operation in this delay. So why we use dynamic path selectors for signal and power supplies? So why? Because when you are using dynamic path means it can change at any instant of time of your operation. It will not be stable from starting to ending operation. Because, so let's have an examples of 3 coils. So this is single pole, single throw. So this will act like as a switch. So this will act like as a switch. When the power supply is 1, then obviously this switch will becomes, when power supply is 0, this switch will becomes open circuited. But if I am giving 1 as my input supply, then it will becomes like this, short in between. There is one more supply, this is single pole but a double throw. So means this one is one set and this one having one other set. If I would like to short the circuit with a single one, this one will operate. For example, let it maybe at 0. If you are giving a 0 as an input voltage, then this angle will come and connect with this switch. And if your input is 1, then the same circuit has to be connected with this side. Then this side will becomes an open circuited, just like as second one. It strictly depends on the operation of electromagnetic principle. That's what exactly what we will learn. When voltage is applied to relay coil, current flows through this coil, where is right. So this is my coil. I have been applied current over here itself. So here I am applying some source in between the 2 coils. Then when current is traveled in between this, what is this? This seems to be like L, inductor, or else winding. When it is current is traveled in along with this one, then some electromagnetic field will occurs over here itself. That is the reason most of the stepper motor and any one of the motors or transformers will be operated like this only. Means what is this one? Electromagnetic field. So how it is going to be generating? When you are applying input voltage over here itself along with the current and frequency, AC voltage, then the winding will create the electromagnetic field with this winding setup. Next one is piezo buffer. So usually we people know about of what is meant by buffer. Buffer contains, so it's just like is just like this one only, piezo buffer only. So it's just like a electrical buzzer. So it's just like electrical buzzers only. So for example, when you are switching on this button, then obviously it will create some audio sound. Or sometimes you can directly having one switch. So if you press that switch